If you are building modern decoupled cloud native applications on the Microsoft Azure ecosystem, you already know that serverless architecture completely changes how we write and deploy backend services. But one of the most critical phases happens right at the provisioning step, choosing how your infrastructure scales, what its security perimeter looks like, and how your billing is calculated. Today we are diving deep into Azure Functions, scale and hosting options. We will look at how the host fabric has evolved, how the internal scale controller operates under heavy resource load, and how to pick the exact right plan for your production workloads. For this deep dive, we have structured our timeline to move sequential from core concepts to enterprise production implementation. First, we will establish a baseline definition: what exactly is Azure Functions under the hood, and what core developer features does it bring to the table. Second, we will lay out the foundational hosting plans available inside the ecosystem. Third, we will do an extensive feature deep dive evaluating networking borders, maximum scale thresholds, cold start impacts, and the explicit structural differences between legacy models and modern serverless platforms. Finally, we will look at an architectural decision matrix to give you a definitive framework for exactly when to choose which plans based on the cost and scale. Let's start with the basics. What is Azure Functions? At its core, Azure Functions is a Microsoft Azure premier serverless compute service. The paradigm shift here is simple. Instead of maintaining an entire virtual operating system, configuring IaaS web servers, or scaling underlying virtual machines manually, you write a small, highly targeted piece of code, a function that responds to an event trigger. This trigger could be an incoming HTTP request, a new message dropped into a service bus queue, a database modification in Cosmos DB, or a scheduled timer event. The beauty of this model is the platform abstraction layer. Azure completely handles running your code, managing horizontal scale expansions, and billing you strictly for your active usage. Your focus exclusively on business logic and code execution metrics, while the cloud fabric abstracts away the compute layer entirely. However, to leverage this power properly, you must make an intentional infrastructure decision at creation time. Let's understand the hosting models. When you provision a new function app inside your Azure subscription, you are required to select a hosting plan. This is not just a nominal configuration step. Your hosting option directly decides the cost of your function runs, your compute capability, and your security architecture. If I go to the Azure portal, if I am trying to create a function app, the first step it comes is the deciding the hosting model. We have different plans here: flex consumption, the premium, app service, container apps, and consumption. In this video, we will understand the different features of Azure Functions and also how to select a right plan for your function app. Let's break down this matrix on the hosting plans. First, we have flex consumption, which is the highly recommended modern standard. This tier is built for most event-driven workloads. It introduces lightning fast scaling combined with native outbound virtual network support and operates on a pure pay-for-execution model. It is currently Linux focused and doesn't support custom Docker containers natively. Second is Elastic Premium. This is your go-to plan for lower latency, always warm, and long-running operations. You are built for second based on your allocated pre-warmed instances, and it fully supports custom container image deployments. Third is Azure Container Apps. This is ideal when your function is part of event-driven microservice architecture. It gives you full container flexibility across environments. Fourth is dedicated plans. These plans running on the standard app service infrastructure. This is best when you have a highly predictable compute load or when you have existing underutilized app service plan capacity that you want to maximize for a fixed monthly cost. Finally, look at the bottom row, the legacy consumption plan. This model is now in maintenance mode. Note this carefully. The classic consumption plan is a legacy hosting option. For all new serverless apps, you should default to flex consumption and you should actively plan to migrate existing consumption apps over to flex. Let's look closer at how these systems handling scaling. To understand how these hosting plans differ, we must analyze three core scaling options available inside the Azure. The first one is dynamic event scale. This is pure serverless behavior. The platform runs an internal engine called the scale controller. The scale controller constantly monitors your trigger channels. It reads message queues depth, check event counts, and evaluates HTTP concurrency metrics. If it sees a massive influx of messages, it dynamically provisions resource on demand to process the load, and then aggressively scale back down to zero instances when the system goes idle. The second mechanism is pre-warmed warm start. This is designed to completely eliminate initial cold start latencies for critical processing paths. The platform sustains a baseline of always ready worker instances that is waiting for the code execution. This dual capability is the hallmark of Elastic Premium and modern flex consumption types. The third model is traditional, manual, and auto scale. This is used inside dedicated app service plans. Here you specify explicit capacity footprints or configure horizontal scaling rules driven by infrastructure metrics like CPU or memory thresholds. Let's compare how the hosting infrastructure itself has evolved. Let's trace the infrastructure evolution from legacy ties to the modern serverless fabric. On the top, we look at the legacy Windows consumption plan, which is now strictly in maintenance mode. It utilized a basic pay-per-use scaling model, but suffered from opaque resource tools where you could not control your worker size, had zero built-in virtual network integration, and relied heavily on a standard file shares for deployment packages, which is causing file lock and scaling bottlenecks. On the bottom, we have the modern Flex consumption plan, the new recommended default for serverless deployments. Flex fundamentally redesigned the execution host. It brings native high-speed outbound virtual network injection directly into a consumption billing tier. It changes the package resolution engine to one deploy, which pulls immutable storage block packages directly for rapid initialization. And for the first time in pure serverless, it gives you deterministic compute choice, letting you pick explicit memory profiles ranging from 512 MB to 4 GB per instance based on your memory demands. Let's examine how this impacts maximum throughput boundaries. When designing for high concurrency event streams or massive data ingestion tasks, you must understand your platform ceiling. Let's look at the maximum instance scaling limits. The flex consumption plan completely resets expectations here by supporting fast, event driven horizontal scale out up to a massive 1000 parallel worker instance per function app. It is specially engineered to handle highly intensive data streams and massive concurrent bursts without throttling. If you look at the other plans, premium and container apps, scale dynamically based on your subscription settings, typically ranging around 100 instances for Windows workloads and 20 to 100 for Linux environments. When it comes to dedicated plans, which are bound to manual or auto scale limitations, scaling between 10 to 30 instances on standard tiers or up to 100 if you set up isolated app service environment. Look at the legacy tier. Legacy Windows consumption cap scales to 200 instances, and legacy Linux is limited to 100. The architectural advantage of the modern tier is Flex offers up to 10x higher parallel compute capacity out of the box compared to legacy options. Let's address networking security next. In enterprise engineering, isolation is a non negotiable requirement. Historically, running serverless meant exposing endpoints or using expensive ties to secure your data pipeline. Modern architecture gives us native inbound and outbound isolation across flex consumption, elastic premium, and dedicated plans. This delivers top tier security without forcing you to provision heavy, expensive app service environment just to get private line communication. Through outbound subnet delegation, your serverless function app is injected directly into a dedicated subnet inside your private Azure virtual network. This unlocks security downstream communication. Your function can completely block the public internet routes, connecting securely to internal backend components like Azure SQL Database, Cosmos DB, or Service Bus namespaces, locked safely behind private endpoints. Note that legacy options like hybrid connections for local on-prem connectivity remain supported on premium dedicated container apps. A common challenge with pure serverless architecture is serverless cold start. When a function app application sits idle, the platform scales it down to zero instances to save your money. When a new event arrives, there is an inherent provision delay while the platform prepares a new host container and mounts your code package. To completely remove this latency for time-sensitive routes, modern plans gives you always ready instances. You can configure a designated baseline of workers to remain warm and active. What makes flex consumption unique is instead of forcing you to pay to keep the entire function app warm, you can selectively assign always ready status to specific latency critical endpoints such as a customer facing HTTP web APIs. Concurrently, you can keep your background event processes like queues or blob triggers running on a pure cost optimized scale to zero model. You accept a minor cold start delay on startup, but your cost scales to absolute $0 when the traffic disappears. Now let's finalize your architectural decision framework into a single concrete matrix. First, choose flex consumption as your default baseline for all new cloud native serverless apps. It is the optimal path when you need rapid high throughput scaling up to 1000 workers, explicit memory tuning, and native outbound virtual network isolation without premium infrastructure. Second, opt for elastic premium, especially for latency critical enterprise workloads that requires absolute zero cold start across the board. Very large memory envelopes up to 14 GB per node, or deployments using a custom Windows or Linux Docker container images. Third, utilize dedicated app service plan for clear cost optimization when you have predictable processing loads or when you have a pre-allocated underutilized app service VM capacity which is sitting idle in your resource groups. Fourth, deploy to Azure Container Apps. Use this particular option when you want to work with large microservices. Finally, avoid the legacy consumption plan for all your new engineering efforts. It lacks virtual network protection, which is limited in the compute size, and Linux consumption is getting retired on September 30th, 2028. Use this tier strictly for maintaining existing Windows installations while you plan to move to modern Flex Fabric. That completes our deep dive into Azure Functions, scale, and hosting options. If you want to review the full technical documentation and deep dive parameters, check the official Microsoft documentation link in the description. Thank you so much for watching. If this video helped you to understand structural difference between Flex, Premium, and dedicated tiers, please give it a thumbs up, share it with your fellow development teams, and drop your technical architecture or migration questions in the comment section below. Don't forget to subscribe to our channel .NET Mirror. I will see you in the next video. Thank you for watching.